Okay, this problem is something related to ozonolysis. So 14.39. So something related to ozonolysis. I think everybody know what is the ozonolysis is, and you can write down the product after the ozonolysis. So this says a compound X on hydrogenation. So X, if I do hydrogenation, it takes 5 mole of H2. So for hydrogenation it takes 5 mole of H2, and this is done on platinum as a catalyst, and this gives N-butyl cyclohexane. So N-butyl cyclohexane is this CH2, CH2, CH2 and CH3. So this is N-butyl cyclohexane you have. So this is N-butyl cyclohexane. So name is not important. So this means this takes 5 mole of H2. So this means this compound must contains 5 double bond, or you can say 5 pi bond. So this contains 5 pi bond. So the compound X. Now I have information, and I have also information about the skeleton. So this is the skeleton of compound X. So a skeleton of compound X I know. A skeleton of X, this I know. Are you getting or not? So what is the skeleton of X? So this I know. Now the next says when X is treated with silver nitrate. So if I treat X, so let me write here, if X is treated with silver nitrate as the NO3, are you getting? If X is treated with silver nitrate in ethanol solution, so ethanol is a solvent, ETOH, it gives a white precipitate. So white precipitate. Now can you tell me what is the test? What is this test? This is a test for alkyne, terminal alkyne. If you have a terminal alkyne, if you treat with AgNO3, it forms a precipitate. So this test says I have a terminal alkyne. So I have a terminal alkyne, so triple bond, and this is in terminal position. So I have a terminal alkyne. So triple bond is a terminal position, and that's why generally we call it a terminal alkyne. So this test gives me this is a terminal alkyne. Now the third part says if I do ozonolysis of compound X, reductive ozonolysis O3 first, and Zn H2O and dimethyl sulfide, this is a reductive ozonolysis. If I do reductive ozonolysis of compound X, this gives the following compound. This gives HCO, and then you have CH2 2 times, CH2, CH2 and CO, CHO. So this is one compound I am getting, and now I am getting COH, another compound COH, and third compound we have, so two more compound we have, HCOOH plus HCOOH. Now see, if you remember some idea, if you do reductive ozonolysis, alkyne will be converted into acid. Either you do reductive ozonolysis or do oxidative ozonolysis, alkyne will be converted into acid. So alkyne will be converted to acid. Now if you are doing reductive ozonolysis, alkene will be converted into corresponding aldehyde or ketone, and alkene will be converted into aldehyde or ketone depending upon the structure of the compound. Now see, so how many acid you are getting? If you look, this is a acid RCOOH. Here I have a acid, so 2 acid I am getting. No another acid. There is a no acid, CHO aldehyde. This is a ketone, this is a aldehyde. So this is a ketone. This means I need a double bond at a position where we will have a secondary carbon. So in the case of secondary carbon, I get only. So this suggests me one carbon should be secondary. This is aldehyde, so this will be primary. This is again aldehyde, so this will be carbon should be primary. Are you getting aldehyde? We can get aldehyde only from primary carbon. So this should be again primary. This should be again primary because these are the aldehyde. Are you getting? Now this is aldehyde. This is again primary. Are you getting or not? This is the acid. So now I am getting acid. So 2 acid. So 2 acid. This means. So let us write. I have 2 acid. This means I will have one triple bond, and that is already we have said. Here you see we have already said there is a terminal alkyne. So this means 2 acid. This means one triple bond. Are you getting? Now how many carbonyl aldehyde or ketone I am getting? So let us count. I have 1 here, aldehyde 1, 2, 3, 4, 5, 6. So I have 6 aldehyde plus ketone. So 6 aldehyde plus ketone total, that is a 6. Aldehyde plus ketone, I have 6. So this means I will have 3 double bond. So this suggests me there are 3 double bond. Are you getting or not? So please keep copying. So I will have 3 double bond, and now I have alkyne, that is a terminal. Now I know a structure of this compound is this. So a skeleton is this. Now I have to fit the double bond. The skeleton is this. Now I have a triple bond in the end. So let us fit the triple bond. Now if you see this compound, now we have to put the double bonds. So first listen and then you write. You see, if you see this compound, I am getting one acid and I am getting this acid. So if I break from here, you will get this acid. So this acid is done. So this side will have HCOOH that you are getting from this side. Now this acid you have, but you have a double bond here. So you have one acid you will get from here. But only 2 carbon and then it's fragmented. So after 2 carbon you must have a double bond. Are you getting? So this is another double bond. Now I have to look for 2 more double bond because total double bond is 3. 1 we have placed. Now I need 1 double bond. This ketone is a secondary. So I need 1 double bond at secondary carbon. Are you getting or not? So either secondary or tertiary you can have. In this case you see this carbon is connected to basically 1 carbon this side and 1 carbon this side. So if you fragment this one, I need something like secondary carbon. So this is possible in the whole case. If I fragment here only, then I can get a secondary carbon. At any place if you fragment you will not get secondary carbon. Now you see there is a hydrogen, you have done. So this is already fragmented. So you will have CHO. So this molecule is done. So this is this one. Are you getting? So this is, let us say this will come from 1. This is unit 2. So this is unit 1. This is unit 2. Are you getting or not? Because you will have COOH, this side you will have CHO. Now I need the, let us say try to this unit. So if you see, I need a CHO. So I am getting from here. So if you see here, CHO I am getting. And then after that I will have CHO and then I have CO. So I have CHO and then if I fragment here I will have CO. Are you getting or not? And then I have 2 CH2, 1, 2. So let us go this side, 1 CH2, 2 second CH2. And then I should have CHO. Are you getting? So I should have 1 CH2 here. So let me see. So once again, so I have count this one. So this is CHO and then CO. I will have CHO here. You see. I will have 1 CHO here. So this is a CHO. Let us see here. You have a CHO here and then CO. CHO is here and then you have CO. And then 2 CH2, CH2, CH2 and then you will have CHO. So this means you have to put 1 double bond here. Are you getting or not? If you put 1 double bond here and if you break, you will get this compound. So from this fragment from here to here, if you see, you will get 3. So from here to here, up to this part, you will get 3. So let us say 3 is this. So 3 is this one. Are you getting? So 3 is what? You see, let us try to see again. I have CHO. So I will get CHO here. And then if I fragment here, I will get CO. Then I need 2 CH2, 1 CH2, second CH2. And then I need CHO. So I should have a double bond here. Now if you see this side, this fourth fragment, if you see the fourth fragment, you will have CHO, CHO. So if you do this one here, you will have CHO and this side CHO. Are you getting? So you will see if the fourth fragment that will come from here, that is CHO, CHO. And that is here we have CHO, CHO. This is the fourth fragment, CHO, CHO. Are you getting or not? So if you see, let us copy this one and then we'll discuss again what we want to say in this case. Basically first we have done, we have looked the position of acid. And if I know there is a terminal alkyne, then I need a acid. So we have placed this terminal alkyne, then broken this bond. And then I looked for, I have a acid group and then I have a ketone group. That is aldehyde group, sorry. So I will have acid here. And then I need a double bond here. Then I can have only SCO group. And once I have this, Now I see there is a secondary carbon. So I need a secondary ketone. So this means I need a double bond here, then only I will have a ketone. So this means this is the bigger part of the molecule, and let us try to find the bigger part. I have CHO this side and there is CO. So if you see the bigger part, you have a CHO here and then CO. Okay, I have CHO, CO, and then I need 2 CH2 and then I need CO, so I have to put a double bond here. So this is all about this problem. So basically, ozonolysis kind of problem can be solved by many ways. You can even use the hit and trial method. So one can use hit and trial method also. That is a good method. You just put the double bond in the ring and then try to, after the ozonolysis, try to see the product. If you are getting the product, that's fine. If you are not getting the product, let us change the double bond, position of double bond. You will get the idea slowly. So ozonolysis questions you can do only by practice. You have to do a lot of practice. So what are the important points in this question? The first important point is, if you do ozonolysis of acid, either the medium is just reductive or oxidative, you will always have acid. That is one point. Now in this case, I am getting ketone and aldehyde because the medium is reductive. If you do ozonolysis of alkene in acid oxidative medium, in that case you will not get aldehyde. Aldehyde will be further converted into acid. In this case, I am getting aldehyde because the medium is reductive, that is zinc CH3 whole twice S, that is dimethyl sulfide. In the presence of zinc, the medium becomes reductive, and that's why we, in this case, we are getting something of aldehyde and ketone. Are you getting? And we said in this compound there are 6 carbonyl compound, so I will have 3 double bond, 2 acid, so I will have a 1 triple bond. If I have 4 acid, then means I will have a 2 triple bond. So triple bond is decided by acid, because in oxidative or reductive acid is coming. In this case, I can say easily acid is only coming from alkyne, because reductive ozonolysis of alkene will never give acid. So acid is only coming from alkyne in this question. Sometime if you have oxidative ozonolysis, in that case acid can come from double bond also. In this case, because oxidative is a reductive ozonolysis, acid can come only from alkyne. And we have also test for alkyne. There is a terminal alkyne. So in this question, this test, that the test with SgNO3 forming precipitate, gives me terminal alkyne. So hint of terminal alkyne. Are you getting? So let us copy this one. Five mole of hydrogen is used. This suggests me there should be 5 pi bond, and 5 pi bond is basically included in 1 triple bond and 3 double bond. That is the total 5 pi bond. I think all of you have copied this one. Try to visualize yourself. Once you know the product of ozonolysis, so these are the product of ozonolysis. These are the product of ozonolysis. Once you know the product, you have to learn yourself how to write down the initial reactant. That is a very useful task. Writing the product is easy, but if I know the product, then writing the reactant is slightly difficult one. And that can be done only through the logic or hit and trial method. So there are 2 ways. Either you can use hit and trial, you put the double bond, do ozonolysis and try to see whether are you getting the product or not. That is one way. Or other way, you try to do some logic. Like you see from the product and give some logic so that you can try to find out the reactant. In these cases, like what are the logics behind? The logic is I am getting 2 acids, so I should be 1 triple bond. That is one logic. And there's we have a test that gives me terminal alkyne. There is another logic. And next logic I have a ketone. So this means I should have a carbon that is in the middle, and it should not be primary. If the primary, I will have aldehyde. So it cannot be primary. This can be tertiary or this can be secondary. So let me write this is basically secondary or tertiary. Are you getting? So if you have a secondary or tertiary carbon, basically not secondary also. If you have a secondary carbon, in that case, we will not getting, I think. So let us try. If you have a secondary carbon, so this carbon is, let us say, secondary. If I have a double bond here, yeah, in that case I can get. If this carbon is secondary and this carbon is tertiary. So if I break this one, then I will get aldehyde. Okay. So if I am getting ketone, there must be tertiary carbon. I will get ketone only if I have a tertiary carbon. If you break this side, you will get acid. Are you getting? If you have a secondary, then you will get acid. So tertiary, this means you will get ketone. So I have a ketone. This suggests me I should have a tertiary carbon. This is not secondary. This is tertiary. If I'm getting ketone, this means there should be a tertiary carbon. And in this compound, if you see, there is only one tertiary carbon. This is another logic we can apply. And if I know this is the only tertiary carbon, then I have to put a double bond here. And if I know only one double bond position, I have to put. So if I see the product, I have to put the double bond here. So this is the logics for this question. We'll go for the next question. Let us copy this one. I think all of you have copied this one.